Then let's begin. So on Monday, we talked about the mean and the standard deviation. Okay. And these are both numeric summaries. And what does the mean tell us? The mean provides a summary of central tendency. Okay, and what does the standard deviation tell us? Spread or dispersion. Okay, and spread or dispersion is the idea of, are the numbers quite similar to each other, or are they quite different from each other? Okay, and so we looked at the kind of the ages of those two fictional families. And we said, in one of the families, the kids are all, 7, 8, 9, 10, 11. So there's very little spread in the ages. In the other family, you had the kids, oh, the text is too small. I forget this. Okay, so let's start over here. Okay. Okay. All right. Okay, so what did I say I wrote? Okay, so on Monday, all right, Monday. All right, so on Monday we talked about the mean as a measure of central tendency. And we talked about the standard deviation as a measure of spread or dispersion. Okay, so let's, this is lecture 4, April 6th. So this is what we have, and I forgot what I was saying. So one family, the ages of kids were had low spread. The other family, the ages of kids, high spread. Okay. And we said, these might be more preferred if the data is symmetric, okay? But really, we could use it for symmetric or skewed data. It's no problem. All right, so today we're going to continue on talking about the standard deviation. And the standard deviation is especially useful because it can tell us, it can be used in determining whether a point is unusual or not. Okay, so we might have the question, is an observation unusual? Okay, is an observation unusual? And for things that we are familiar with, we can say, oh, that's unusual. Okay, if we see a person who is 7 feet tall, we would say, oh, that's very tall. That's unusual, unusually tall, okay? Or, and so we have a sense of things, things that seem strange or unusual, right? But, for things that are not so familiar to us, the standard deviation can help us here, okay? And so to get an idea of what is unusual, well, let's talk about what is usual. And we can quote, define usual or typical, can be, loosely, can be defined to be something close to the mean. Okay, so a lot of people are between the heights of 5 feet tall and 6 feet tall, and this would kind of be the range of what might be considered usual. And I don't know what the mean height of all people is, but it's probably around 5'6", 5'7", or something like that. And so things that are relatively close to what's the mean, what's the in the balance point of our data, can be regarded as usual, okay? Whereas unusual will be defined as things that are far away from the mean, okay? Okay. But, you know, if we think about it, you know, what is far away from the mean, okay? If we're talking about cars, and, you know, let's say the average price of a car that you can purchase is, I don't know, $30,000, okay? If somebody spent $40,000 on a car, would you say that's unusual? No, that seems fairly reasonable, okay? If somebody spent $20,000 on a car, is that unusual? No, that seems reasonable, okay? And that's $10,000 away from the quote-unquote average that we have established here, okay? All right, let's talk about, I don't know, let's say the average price of a hot dog is, let's say, $3, okay? I don't know, I'm making that up. Costco, it's $1.50, but, and you get a drink. But okay, so let's say the average price of a hot dog is $3, okay? If somebody spent $100 on a hot dog, is that unusual? Yeah, you'd say that doesn't sound right, okay? But that's only $97 more than average, okay? So when we were looking at car prices, you looked at, you know, 10,000 more than average, nobody batted an eye, okay? You spend $97 more than average for a hot dog, then you're like, whoa, something's going crazy here, right? You know? We can't just talk about just straight distance from the mean, okay? What we're going to do is we're going to talk about distance from the mean, but expressed in standard deviations. Because if we have a standard deviation that tells us the spread, then we can say, okay, this is very unusual or not, okay? So it's not enough to just have the distance from the mean. We want the distance from the mean expressed in standard deviations, okay? Okay, so we're going to have this definition, the z-score. A z-score is the distance an observation is from the mean expressed in standard deviations. Okay, so I'm just abbreviating that SD, or just S, really. That's the symbol we use for standard deviations. Good? No, not yet. No, it's good that you shake your head, because then I'm like, oh, okay, don't move. All right, how about now? Not yet, okay, that's all right. Okay, I got the smile and the head nod. All right, so let's say, and I'm totally making up these numbers, so don't go to the Department of Labor and ask about this. Okay, so let's say the average age of retirement is 61, okay? And this will be in the USA. Okay, I'm, again, making this up, okay? And we'll say the standard deviation of retirement ages is, we'll say, 4 years. Okay? And so what this means is that a person who retires at age 65 has a z-score of what? Of 1. Okay, positive 1. Okay, someone who retires at age 61 has z equal to 0. Okay, so because the z-score is how far is this observation from the mean expressed in standard deviation. So if someone retires at age 61 and that's quote unquote the average or the mean, then that person is 0 away from the mean. Okay, and you know, a person who retires at age 57 has z equal to what? -1. Okay, because this person retired 4 years lower than the mean age, but every 4 years, standard deviation is 4 years, okay? And so this person is 1 standard deviation below the mean. Just want to make sure this is okay. We can all add and subtract 4, see where we're getting 65 and 57, stuff like that. Okay, well, this is, so this kind of stuff is helpful because we have the empirical rule. Okay, and the empirical rule says something along the lines of, and this is, you know, this is true for, okay, wait, empirical rule, it says for many data sets, we can say about 2/3, or more specifically about 68%, so a tiny bit more than 2/3, 68% of the data are within 1 standard deviation of the mean. Okay, and that means, you know, have z-scores between -1 and +1. So about 2/3 of the data have z-scores between -1 and +1. We're going to say about 95% of the data are within 2 standard deviations of the mean. Okay, or I can just say -2 is in between z less than +2. Okay, and almost all so about 99.7% are within 3 standard deviations of the mean. Okay, so the empirical rule is also known as the 68, 95, 99.7 rule. Okay, so these would be 3 numbers that are good to remember. So here we're saying, okay, Next slide. Okay, so all right, so what does this mean? So we'll talk about retirement age again, and again I'm just making this stuff up. All right, so we're going to say we're going to say something along the lines of 68% of people in the USA retire between the ages of what and what. So retirement age, we said the mean is what did I say, 61, and the standard deviation is 4. So if 68% retire within one standard deviation of the mean, so 68% of people in the USA retire between the ages of what? 57 and 65, right? We're okay with that. So 57 has z-score equal to -1, 65 has z equal to +1. Okay, so then complete this sentence. 95% of people retire between the ages of, and you would say 53 and 69. Okay? And then we would say, nearly all, or 99.7% of people retire between what? 49 and 73. Okay, and so this is the empirical rule, and again I've made up these numbers, but this sounds like reasonable statements to make. I don't know if they're true or not, but they sound kind of reasonable. All right, and so we have this. Okay, and so this also sheds light on that question I posed just a few minutes ago, which was, is an observation unusual? Okay. So if we know that about 95% of people or the data will have z-scores between -2 and 2, we can then say, well, if you've got a z-score more than 2 or more negative than -2, that's a little bit unusual, okay? Because we expect only what percent of data to have z-scores greater than 2 or less than -2? Only about 5%, right? Okay, so what is unusual? Okay, we would say if the z-score is greater than +2 or less than -2, we can say it is unusual. All right, only 5% have such z-scores. Okay, and then if the z-score is, if z is greater than 3 or less than -3, then it's really unusual. And again, these are rules of thumb. So sometimes you've got extremely skewed situations where maybe this isn't as reliable, but this is pretty good. Okay, z-score is greater than 3 or less than -3. That's pretty unusual. And then every now and then you'll get like a z-score of +6 or something. Okay. And so if a z-score is 6 standard deviations away from the mean, then that's like really, really, really unusual. Okay, it's like a 1 in a million or 1 in a billion type of situation. Okay, z-scores also allow us, so now that we have a way to say what's unusual or what's not unusual, z-scores now allow us to make comparisons between apples and oranges. Okay, so with z-scores, I'm sorry, did I flip the slide too quickly there? We're okay. Okay, so with z-scores, we can make comparisons between different groups. Okay, so if you follow sports, there's something very exciting happening in the NBA, and the Golden State Warriors, they lost last night, which was sad, but they might break the record of 72 wins in a season. So I don't know if you guys care. There's 82 games in a regular basketball season, and the current record is 72 wins, and that's Michael Jordan's team. And they have a chance to beat it. Okay. Also amazing is Steph Curry. He's a player for the Golden State Warriors. He might make 400 three-point shots in a single season. Okay, which is an amazing record, because the prior record to this was like 280 something. Okay, so this is like blasting that record out of the water. It's really crazy. Okay, so he's at what, I think 282. He has like 4 games left to make another 18. He might be able to do it. Okay, so anyway, 400 free throws is akin to making like 100 home runs in a baseball season, which maybe if you don't follow basketball, I mean, it just sounds like gibberish right now. But 100, I think the current season record for home runs is, does anyone know? It's like 72 something. Barry Bonds, how many did he hit? Come on, guys. Come on, people. All right. All right. Well, I don't know. Okay. But so hitting 100 in a single season would be quite remarkable, and we can ask which one is even more unusual. Here, we'll change this. Okay. So what is more unusual? We'll say a Chihuahua. How much? Okay, Chihuahua that weighs I don't know, 10 pounds, or a Great Dane that weighs, I don't know, 180 pounds. Okay, so these are both dogs, and dogs are, it's an amazing thing. They're all of the same species, and yet you have this huge variety of animals. Okay? All right, so what's more unusual? The Chihuahua that weighs 10 pounds or the Great Dane that weighs 180 pounds? What do you think? Chihuahua? Okay, so, well, this would involve requiring us, okay, what's the mean weight of a Chihuahua? And we can go to Google. And so I think I looked this up. Okay, so we said average weight of a Chihuahua, it says 3.3 to 6.6, so I don't know, the mean weight, I guess that would be, what, 9.9, so 5? Okay, so we'll say the mean weight is 5 pounds, and I'm going to just make up the standard deviation, we'll say is 1.1 pounds. Okay, I don't know, I'm making that up. Okay, and then the Great Dane, I looked this up, average weight of a Great Dane, and here it says the males go between 120 to 200 pounds, so those are big dogs. So we'll say, we'll split the difference, and we'll say the mean is 160 pounds, and the standard deviation is something like, we'll say 20 pounds, okay? So what can we see here? We would see, the z-score for the Chihuahua would be what? It's the distance from the mean, so we would do 10 minus 5, but we would take that distance and we wanted it expressed in standard deviations, so I would do 5 divided by 1.1. No, that's not helpful. 4.55, we have a z-score of 4.55, whereas for the Great Dane, how far is it from the mean? Its z-score we can see would be what? 1, right? Okay, so if we look at this, we can say, oh, well, the Chihuahua, this is far more unusual. 180-pound Great Dane. It's a big dog, but it's quite average, quite typical for as far as Great Danes go. I didn't realize that they were that big. That's What's the biggest dog breed? It's like some Mastiff, right?
Russian bear dog.
Huh?
A Russian bear dog.
Russian bear dog? Let's see how big this thing is. I want to see. How do you know this? What is this thing? Okay. What? It says AKA the Russian bear dog. This belongs in a zoo. Oh, he's so cute. Okay. Okay. Well, next time we'll ask about the Russian bear dog. Okay. Well, thank you for that. We all learned something new today. Well, I hope you learned something new about statistics today. Okay. So anyway, that's z-scores. And so we can make comparisons and things like that. All right. We also said on Monday about for skewed data, we have like the median and the IQR. Okay. So the median to measure center, and we have the IQR. And the IQR measures spread, and this is defined as the the name of it is the interquartile range. Okay. So if you studied your word root etymology, IQR will be defined as Q3 minus Q1. It's the distance between quartiles, quarters here. So Q3, or I'll say Q1, is our first quartile. The first quartile is the 25th percentile. Okay, and this is the spot where 25% of the data is smaller. Okay, we will say there's technically a Q2. This is really the median. The median is the 50th percentile. Okay, and I think you guys are probably familiar with the concept of a median. Why am I having trouble writing here? 50th percentile, this is the spot where 50% of the data is smaller. Russian bear dog, that's crazy. All right. I wonder how much food they eat. I'm imagining taking this thing for a walk and you're like, oh, sorry, neighbor's lawn. You're gonna have to take a wheelbarrow with you. Third quartile, 75th percentile, the spot where 75% of the data is smaller. Okay. Okay. So the median is kind of our measure of center. We can think of it as the halfway point. This would be the halfway point of our data. It doesn't even need to be in quotes. It really is the halfway point of our data. Okay, so that is that's the median. And so when we talk about things, you know, I'm just making up an example here. So I don't know. Let's say we went around and we asked everybody how much money is in your bank account or something like this. Okay, and not that we would do this. You know, I'm just making up numbers. So you know, maybe we have a classroom of 160 students. Okay. You know, if we say the median is equal to, so we'll ask how much money in your bank, right, account. I guess this assumes that you guys have bank accounts, and a lot of people don't use bank accounts. Okay. But okay, so we'll just assume everybody has a bank account here. Okay, and let's say, I don't know, the median is $812. Okay, so this means 80 students. I'm making this up. Okay, so I don't know if this sounds really high or low. 80 students have less than 812, and 80 students have more. Q1, again, just making this up. So don't ask me, where did I come up with this number 812? I'm just making this up. We'll say Q1 is $203, okay? And so in a classroom of 160 students, 1/4 of the students, so that would be 40 students, have less than 203, okay? And 3/4 have more, all right? In Q3, we're just making up all of these numbers here again. Maybe this is 1740, 40, okay? So we'll say 3/4 of the students, so 120 students have less than 1740, okay? So our IQR would be Q3 minus Q1, 1740 minus 203. What is that? That's 1537. Okay, so this is the range of the middle 50%. Okay, so this is the difference between the 25th percentile and 75th percentile. So this is the range of the middle 50% of students, and that's what we're saying. Okay. And this gives us an idea of spread. Okay, so without having to do the standard deviation and finding the average square distance of the mean, this is just another way to say, okay, is the amount of spread here a lot or a little? Okay, if we were to go to a different location, okay, maybe we were in some place that was dealing a school that was for specifically for low-income students. Okay, all right. And so in that place, for a place for students with low-income students, we would not expect the greatest amount of money in the bank account to be that high. Okay, and the lowest amount is probably going to be fairly low. But the range, the spread between the 75th percentile and 25th percentile will, probably be quite small, because if everyone's low income, maybe the rule is you can't have this much money in your bank account. Okay, maybe it says like, okay, for you to be considered low income or whatever, you can't have this much income and you can't have more than $500 in your bank account or something like that. Okay, well then by necessity your IQR can't be, you know, more than 500. Okay, maybe the richest has 500 and the poorest has 0. The IQR is going to be probably even less than that. So we get an idea of the amount of spread, or you know, how different are these values from one another by looking at the IQR. Okay, so let's talk about finding these values if I were to give you a set of numbers. Okay, so we'll say finding the median and IQR. Okay. All right, so step 1, this is the most important step. And that is arrange the values from least to greatest. Okay, if you don't do this step, you will be in trouble because all of your numbers will be wrong. Okay, so let's say we have 12 test scores. Okay, and let's say our test scores, I'm just making these up, 60, 70, 72, 77, 78, 80, 83, 85, 88, and 90, 92, 96. Okay, I'm going to want to use these again later, so I'm going to just go ahead and copy these. Okay, so let's so find the median. Okay. So we have 12 test scores, so the median will be the spot where half are greater. So we're going to do 12 divided by 2, and we'll say, oh, 6. Okay, so 6 will be, half the values will be smaller than the median. So 6 values will be less than the median. Okay, so I'm going to say, okay, because these are arranged in order, I'm going to just count 1, 2, 3, 4, 5, 6, and I'm going to draw a line here, okay? And so I've got 6 values that are smaller. I've got 6 values that are larger, okay? So my median is in between 80 and 83, so my median will be equal to the mean of 80 and 83. Okay, so my median is equal to 80 plus 83 divided by 2. I get a median of 81.5. All right. Okay, so then our quartiles, Q1, first quartile. Basically, I just want to split our list into quarters, okay? And so just imagine having a piece of bread, or like a loaf of bread, that's not sliced. You'd cut it in half, and then if you wanted it in quarters, you would just take each half and you'd cut it in half again, right? Like you're going to Subway, right? You get foot long, cut it in half, and then you're like, oh, I only want a quarter of this thing because whatever. So that's all we're going to do. Okay, so now I'm going to pretend like this median split my list into 2, and I'm going to find the spot halfway of these 6 numbers. Okay? So where would my Q1 be? Okay, so then we'd say find the, quote, median of the lower half. List. Okay, so what? So Q1 is what? Right here, right? Okay, so Q1 is equal to 72 plus 77 divided by 2. I get Q1 is equal to 74.5. Give me a A smile and a nod. We're good? Okay. All right, and then so if that's what we do for Q1, Q3 is we do the same thing but just on the upper half. And what's our Q3? So you can just shout out a number. So Q3 will be what? 88 plus 90 over 2, 89, right? So this is Q3. Okay, everybody's good? Okay, and then so our IQR would just be 89 minus 74.5. I've run out of space to write this, but I'll just throw it right here. IQR is equal to 89 minus 74.5, and I think that's what, 14.5? Something like that. Okay. Great. Okay, and then what we do if we had an odd number of values is ever so slightly different. So we'll go ahead and show you that now, and this should cover kind of every situation, I think, in terms of finding the median in IQR. Okay, so here I'm going to just add a few values to this same list. I'm going to just append, we'll stick on 57, a value lower, and then I'll stick on 2 values higher, 99 and 100. Okay, so here I have 15 values now. Okay, so to find the median, I'd say, okay, well, 15 divided by 2, this is 7.5. Okay, so I'm going to have, so what I'm going to do is I'm going to say, okay, I'm going to have 7 values that are smaller, 7 values larger than the median, and 1 value equal to the median. So, because I'm getting 7.5 here. So I'm going to count. I'm going to go 1, 2, 3, 4, 5, 6, 7. And then I'm going to say, okay, this is my value that's equal to the median, and then I've got 7 values that are larger. Okay, I got 1, 2, 3, 4, 5, 6, 7. 7 values that are larger. So my median is equal to 83. Okay. All right, and then to now get our quartiles, and depending on what textbook you read, they might say different things. Our textbook says to do this, and that's what we will do, is now you just take this list of 7, and then you do the same thing. Okay, so we're going to look at this list of 7. So we have 7 values. So 7 values. Okay, so we have 7 divided by 2, 3.5. Okay, so that's going to have 3 smaller, 3 larger, and 1 equal to Q1. Okay, so what is Q1 then? So so we look at 3 smaller, 1 equal, 3 larger. Okay, so because we're just looking at just basically this half of the list now, right? We got 7 values here. Okay, so my Q1 is equal to 72. All right, and what is Q3? Q3 would be 92, right? 3 smaller, 3 greater, 1 equal. So Q3 is equal to 92. So our IQR would be 92 minus 72 equal to 20. Are there any questions before I move on in our last 3 minutes of class? So we're all good. We're all good with finding IQR and the median. Okay. Okay. So then, so finally, we'll just do a quick comparison of the mean versus the median. Okay. So the mean can be thought of as the balance point of our data. The median can be the halfway point of our data. The mean is affected by extreme values. Median is not affected by extreme values. Okay. I'm going to put quote preferred for symmetric data. Preferred quote unquote for skewed data. Okay, and then so if you have skewed data, something like this, and I'm just going to cartoonishly exaggerate what's going on here. So this might be the median, and over here you have the mean. Okay, and what we say is that the mean is pulled out in the direction of the skewed. All right, let's compare the standard deviation versus the IQR. Affected by extreme values, not affected by extreme values, I can just kind of copy and paste that. And then you kind of have your loose definitions for what the standard deviation and what the IQR are. You know, the range of the middle 50%, or okay. Just trying to. Okay, I think that's it. So we'll see you guys on Friday, and have a good day.